This video, we're going to continue on talking about stacks. So in the first video, part one, which you should start with, we talked about the idea of a stack, and where a stack is basically a data structure where the first one in the stack, this one, will be the last one out of the stack. Okay. So we have some basic operations we're going to have for the stack. We'll talk about that in a minute. The real basics are you push things onto the stack, you pop things off the stack, and you can access the top element of the stack with the top function. Okay, so really the push, pop, and the top are the main functionality that we have. Okay, you're also going to have an is empty, is full, things like that. Okay, so we have talked before, there are two ways that we can represent this, either as arrays or an array, or as a linked list. Okay, the linked list will be in video 3. So we'll talk today about linking it as an array. Okay, so the idea here is if you have an array is of a fixed size. Okay, so we're going to have this max size, okay, of our array, and however many that we have, we'll then have our pointer to the array name. Okay, I think the example we're going to use calls it list. Okay, so you have a list there. Okay, it's just an array. So the way we're going to do this, in this initial condition, okay, the list is empty, there's nothing there. But as we start adding items to the stack, we're going to view this side as the bottom of the stack. Okay, so again, the bottom down here. Okay, and this side will be the top. Okay, this is going to allow things to expand. We can't do it the other way because we can't expand beyond to the left of the 0. Okay, so if we were to say push a 5 onto the stack will now be there. Okay, and let's think about how we can figure out where we are in the stack. Okay, we're going to need another variable. Okay, we can call it, let's see what I want to call it, stack top. There we go. Okay, so let's say stack top is going to be an integer. Okay, and this integer is going to point to the location where we start. Okay, so this stack top always has to point to one beyond what we're actually doing. Okay, so stack top points to 0. Okay, if it points here, this is saying that we have empty stack. Okay, so when we add this 5 into the first position, we have to make sure that we increase the stack top to be 1. Okay, and then if we do another push 15, the 15 will go here, and the stack top now goes to 1 beyond that. Okay, or at 2. Okay, this means at any point if we want to access it, we'll be doing a list of the stack top minus 1. Okay, this is the only element that we're going to be able to access. Okay, the rest of the elements are hidden from us. Okay, that we call it actually max stack size. So that's the idea. We keep pushing. So if we push 25, okay, 25 goes there, and the stack top now points there. Okay, if we do a pop, keep all in the same color, do a pop, we'll return that 25. No, pop will do nothing. Pop will delete the 25. Okay. So now that's gone, and we have to decrement the stack top back to there. Okay, if we do a top, switch over to here so that doesn't pop up, a top will return the list at stack top, which is integer minus 1, okay, which in our case will be a 15 in our current position. Okay. So that's the basic way it works. It's relatively straightforward. Okay. So on this one, we're actually going to go through the code. Okay. So on the last one, on the linked list, it's going to be left as an exercise for the viewer. But for this one, we're actually going to go through that. Okay. So let's get out of here. We'll leave that all together. Shouldn't need that anymore. Okay. And now we're going to go over to the terminal. Okay. From the terminal, we can take a look at the code. Okay. So we're going to start off here on the terminal with this is the, as you can see, you can't see, there it is, the stack ADT.h. This is the abstract data type that we created, so that we're going to have the same function names and the same parameters, the same function signatures for both the array version and the linked list version, which means it should be relatively straightforward to move things back and forth between them. Okay, so this is the code we did last time. Again, it's our stack ADT, abstract data type. We can't create an object of type stack ADT because it has these pure virtual functions. Okay, so these pure virtual functions, again, are an obligation to us. When we create the stack array or the stack linked list, we're going to have to implement all these in their exact versions. So we're going to have an initialize stack that takes no parameters and it's a void function. We have to have an is_empty stack, is full stack. We have to have a push, which will take, and again, this is a templated function. The type is just, you can type can be whatever you want to call it, but the type variable here is called type to make things easy. Okay. So we're going to have a push function, which is going to push a new item of that type onto the stack. Okay. We have a top, which will return whatever items on the stack, assuming it's not empty. And then a pop, which will remove that top item. Okay. So all those have to be there. So I'm going to call mine stack array.cpp. Okay. And I've started a little bit of this, and we'll kind of go through and add some detail as we go. Okay. So we started again. This is the template class type, so we can have a stack of ints, a stack of doubles, a stack of whatever we want. Okay. And then this stack array class is going to inherit in a public manner from the stack ADT. Okay. It had a type variable also, so we got to put that in there. Okay. So the private variables we're going to have. So these are things that we need for the particular array implementation of the stack. We're going to need an int called the max stack size. That's an array has to be created at a certain size. Okay, we're not using vectors that are variable. Okay. Note these are dynamic arrays. They're being created on the fly. Okay. So we have an int stack top, which will be the array position at the top of the stack. And again, we're going to model that being one beyond the last item, just so we can keep track of things and we can deal with that first item. If you didn't do it that way, if you had a one-to-one correspondence, you wouldn't be able to access the first item of the array. Okay. So then we have our pointer. Remember, an array is just a pointer and a pointer is an array. Not all arrays. All arrays are pointers, not all pointers are arrays, but in this case they are. So we're going to create a pointer to array of type, ints, floats, whatever we're sending it in. Okay. And because of this line with the blinking cursor here, because we have memory data, we're going to have to make sure to avoid shallow copies and unpredictable behavior. We're going to have to make sure that we have a that we overload the assignment operator, the equal sign, and that we have a copy constructor. Okay. So to aid in that, we're going to make a function that does the basic copying over. Okay. We have to copy over the whole array. Okay. So to do that, I create this copy stack function. Okay. Which is going to take some other stack. So this is a void function, but it's a private function because it's going to be called when we're overloading the assignment operator and when we're creating the copy constructor. Okay. So we can go ahead and probably come back to that. Okay. So let's actually go down and start with the regular constructor. Okay. And again, I've just copied over all of those function signatures. Okay. All the things that they take. So we have here the stack array, which is our regular constructor, which takes an int for stack size. The equals 100 means that if we don't give it a value, it will default to 100. Okay. So on this, not too much going on here. We just have to make sure that we're not going to end up with a negative number, okay, or 0 as a stack size, because that wouldn't make any sense. So I have an if statement here. We're going to say if, I lost my space, if small s stack size is less than or equal to 0, okay. If this is the case, we're in error here. That's not what I want. That's what I want. Okay. So we can see out some kind of error message. Array must be a positive size. And then we're going to go ahead. We could ask them again. We could do something, but we didn't ask them the first time. It's coming in as a call from a function. So it's better to go ahead and do something like a default to 100. Okay, if they don't like that, they can rerun the program again. Okay, that should create it. Okay, and then we're just going to set the max stack size equal to 100. Okay, the same as if they'd done nothing. Okay, and if they would have done nothing, the stack size would be equal to 100, and it wouldn't hit inside this if statement. Okay, we then have an else here. The else is going to be that the max stack size is equal to the stack size we passed in. Again, if they pass in nothing, it will be 100. Okay. So now we've got the max stack size taken care of. We have to set the initial stack top being equal to 0. Okay. And we also have to create our new dynamic array called list. Okay. So list is equal to new type. Remember, type is a variable that holds the data type of this, of max stack size. And we know that's not going to be a 0 or less than a 0. Okay. That's all we've got. We can then end our constructor. Okay. So we then, so there's our constructor. Okay. So I would normally run this, but because I put all these things in here, I think it probably would blow up, maybe, since there's no bodies. So we'll go ahead and create the rest of this. Okay, so let's go back and we'll start with the initialize stack first. Okay, and we'll move forward. Okay, so the initialize stack, pretty straightforward. Okay, all we have to do is set the stack top equal to 0. Okay. That does it. Okay. These is empty stacks, pretty straightforward too. We're just going to return the Boolean, it's a Boolean function, okay, whether or not the stack top is equal to 0. If the stack top is equal to 0, so if that is true, then is empty stack is true. If that is false, then is empty stack is false. Okay, so pretty straightforward there. Okay. The is full stack is also pretty straightforward. We're going to return another Boolean expression. If the stack top is equal to the max stack size. Okay. So again, if you have a stack max stack size of 100, your array will go from 0 to 99. Okay. So therefore, if you were at that last element, that 100th element, it would be at position 99. For it to be at 99, the stack top would have to be at 1 plus that, or 100. Okay, so this, if the stack top is equal to the max stack size, then it's true that it's full, and if it's false, it'll be false that it's full. Okay. Okay, so we've got those. The next thing is the push. Okay, so the push is going to take a new item of whatever type that we've set for this, integers, floats, whatever. Okay, and it's going to add it to the top of the stack. Okay, so if we remember back to the preconditions of this, it has to be that the stack can't be full. If the stack is full, you can't add anything to it. Okay, so if it is not is full stack, okay, so it's not this case, so we're good. We can do something here. Okay, you could do this the other way around, do the error message first and then the actual work. This is going to say things are okay we're not at a full stack, but I do have to spell full correctly or type it correctly. So then we're going to take list at the stack top position. Okay. Remember, stack top points to the next array index past the end of the data. Okay. So stack top is the new top element. The top contains nothing typically. Okay. So that's going to be equal to our new item. Okay. And then we also need, of course, to take the stack top plus plus to move that up one. Okay. That's going to take care of that part. Okay. And then we have an else here. Again, we could have done this the other way around if you prefer. Else see out that you cannot add to a stack. Pretty basic there. Okay. And then this is going to end the push function. Okay. So we've got the is empty stack, we've got the initialize, the is empty stack, is full stack, we've got the push. Okay. So the next thing we have is the top. The top returns the top element. Okay. So top has a couple of things we have to worry about. Okay. If the stack is empty, we're going to do another technique. We're going to use the assert. Not sure if we've used that or not before. The assert is a function. It's in the C assert library, so we have to go and include that. Okay, up at the top in the includes. But the assert is kind of cool. It's a Boolean. If it's true, it totally ignores it. If it's false, it will terminate the program. Okay, and you may want to go some different way, but I think it's just an example of something we could be doing. Okay, so I'm going to assert that stack top is not equal to 0. Okay. So if stack is empty, we're going to terminate program. And you may not want to do that, but we're just going to show that as an example. Okay. If we're to this line, we know that stack top is not equal to 0. So we can return our dynamic list array at that position, stack top -1. Okay. You don't need the spaces, but you can make it look nicer. Okay. That's it. That's the end, the top. Okay. At this point, I'm going to go and make sure that my C assert is being included. If not, it's going to give us errors later. In fact, nothing's being included. So I'm going to go back up and include IOStream. I'm going to include the C assert. We also need to include, and it must be the same directory, the stack adt.h. Okay. If you don't have that, not going to work. Okay. So now we can go back, and all we have left is the pop. Okay. So for the pop, we want to check to make sure that the stack is empty. So again, 2 ways to go. We're going to do it the same way we did it on the push. We're going to say if not is empty stack. Okay. So if it's not is empty stack, then we're good. Okay. We can go ahead and take the stack top -. Okay. So let's think about what's happening here. We're not getting rid of what was at that position. Okay, because we don't need to. There's always random stuff in your array unless you go through and initialize it to 0. We're never looking at anything except what's at stack top. Now, the things that are lower in order added before, we need to maintain those because we're going to go back as we deplete the list. Okay, but we don't have to worry about deleting that item. If we go to push another one, it's just going to overwrite what's there. Okay, as far as deleting the data structure, deleting the array when it goes out of scope, we don't have to worry about that. We thought we needed a destructor. We don't need destructors anymore. Okay, so there's some automatic garbage collection. So we don't have to worry about that at all. It'll all go away when an object of type stack goes away. Okay, so we don't have to worry about it. That's all we need. Okay, And of course, if the stack is not, or if the stack is empty, then we have to see out that we cannot remove from an empty stack. I don't know why everything's in capital letters, but hey, such is life. Okay. So that takes care of that one. And now we can end the pump. Okay. And that's really the basic structures of what we're going to need here. Okay. And again, I normally would have tested all this, but I'm going to have to live dangerously and allow for lots of typos and lots of errors. Okay. So let's now go up and deal with this overloading the equals operator. Okay. In fact, first, let's do this copy stack. Okay. So copy stack takes this other stack. So in this, we'll have a this. Okay. We don't need this. Sorry. We'll just have the list and all that stuff we can do. Okay. So we're starting here. And again, the other stack is getting copied to the stack that's on the left side here. Okay. So we can start by saying delete list. Okay. So that's the list of the stack on the left-hand side. It's gone. We're getting rid of everything. It's all gone away. Okay. Out of memory. Okay. Then we can let max stack size be equal to the other stack dot stack size, max stack size. Okay. So we're setting that up. Okay. We're going to let the stack top be equal to the other stack dot stack top. Okay. We're going to recreate our list. So list is equal to new type max stack size. And again, we had to delete it and recreate it because there's no guarantee that they're going to be the same size. Okay, so when we're done, the one to the left, or the one that's calling this function, should have the same size if it's going to be identical to the one on the right. It may not be big enough to hold it. So that's why we're deleting it and recreating it. Okay. Then once we've done this, we now have to copy the other stack to this stack. Okay. We do that with a for loop for int I equals 0, not a no, that caused trouble. I is less than the stack top. We only need to go as far as we have values, plus plus. Okay. Remember, this will not include the stack top. The stack top does not have data. For each of those, we're going to say list I is equal to other stack dot list sub I. Okay, that's going to go through and copy everything. That's it. We're done with that one. Okay. So we can now, not like that typo, 1 bit. Fix that. We can now move on to the overloading the assignment operator. Okay, we're going to avoid a self copy by saying if this does not equal to the address of other stack. Okay, if it did equal to the address of other stack, we wouldn't need to copy it. It'd already be in the same place. Okay, we'd be deleting it and adding it back for no reason. Okay, but if that's okay, we're going to say copy stack other stack. Again, using that function we just created. Because this is defined inside of the class, then it's okay. It can call this, even though it's private. Okay. So we've got that one. We've got the initialize stack. We've got the is empty stack. We've got the is full stack. Got the push. Got the top. Got the pop. We've got the default constructor. And now we've got the last thing will be the copy constructor. Okay. So the copy constructor is going to look kind of like the overloading the assignment operator. But in this case, we're going to set list equal to null. Okay. And then we're going to do a copy stack. Other stack. And the other stack was passed in. Okay. That's all that does. And a copy constructor. Okay. That's all we got there. Okay. So I should be able to compile this now. It won't do much, but it should at least show me if I've got any major typos. If not, I'll be a little bit worried. There we go. I should be a little bit worried. Okay, I'm at line 108. Let's see where we are. Control V takes me down a bunch. There is no 108. Yeah, I guess there is. Oh, I keep doing this. That is not really anything except a label, so I have to put a label there. That's all it was. Okay, all kinds of stuff now. Oh, yeah. Look at those error messages. If you mess something up with your stream operators, you get a ton of messages. And all that is because I forgot by using namespace standard. Okay. Fix all those errors, hopefully. So I got something else. Okay. Oh, something else I always forget to do. Oh, that must be the other one. Yeah, that's in the stack ADT. Okay, so let's look at what it's saying here. It's saying that from the stack ADT, I've got this if not defined stack H. I don't have an indef in that one. Okay, so I have to go back and do that. Okay, so let me go back to stack ADT.h. There's my if define. I go to the end, and in fact, I do not have my end if. Okay. Try it now. That part's okay. Other issues, we got that. Okay, so this is in the equals operator. Okay. Let's see what it's saying there. Other stack was not declared in this scope. So let me see what I've done. Okay, so this is going to be here on the equal operator. Oh, I've got, let's see. This should be saying, let me find my cheat sheet here. Oh, I didn't put the name. It's operator equals constant stack array type address, has to have a name. That should fix that one. Okay, this just says that it's expecting a main and didn't have a main. So we're good on that. Okay. So far so good. Doesn't mean we're perfect, but hopefully we're okay. So the next thing we need to do, and I'm not going to do all this, it's a long video already, but I'll go ahead and test out a few of the basic operations here. Okay. Again, you're going to want to check every single function and all of its variants to make sure that it works. Okay, so go down here, create my int main. Start with the stack array. Let's do it as an int. You have to type it. Call it S1 of 50, let's say. Okay. We could do a stack array int S2 of 0, which should be equal to 100, just to see. Okay. And let's create another one to test our copy one. We can do a stack array int. Let's call this copy S1, also 50. Okay. Just so we can copy something into it later. Start with an S1.initialize stack. Okay. And then I'm going to do an S1 dot push a 5. Copy that down. Going to enter 1, 2, 3, 4 of those. The tab key will line it back up. 15, 25, 35. Okay, so they're all there. Okay. And now let's go through and print out the whole stack. Okay. So we can do a while loop here. Got to find the home keys first. While not copy S1 dot is empty stack. So while it's not empty, we're going to see out the current element. Okay. Oh, we haven't done anything with the copy yet. So let's do our S1 first. S1 dot top. Okay, the top returns the value. And we'll do a quote there. Okay. So that prints out what's at the top. But then to move to the next one, I have to remove that. Okay, so I have to then do an S1 dot pop. Okay. That should print out all of our values. We'll just see if that much is working. See if I have any typos there. I very well may. Yep, got something. Yep, doesn't like that on line 126. It's 1. It's okay. Haven't done that in a while, so type in A dot out. Okay, the first time it says the array must be a positive size, which is correct. It's going to default 100. Okay, and then, oh, I forgot to do a new line character. Even on your test programs, you want to make them as neat as you can. So after the while, see out. Okay. But keep in mind, though, that this process has depleted our list. It's not there anymore. It's gone. Okay. I can do that, but if I want to do a see out S1 dot top now, okay, just to see. Okay, put in a after print. New line character there. Run this. Okay, you got trouble. I wonder why we have trouble. Oh, we have trouble because we've ran into an issue with our assertion error. Okay, we've ran into an issue with our assertion error because if we look at this, we can see what's happening. Okay, the assertion error happens with our assert keyword here. When we go to the top, if the stack's empty, we're terminating the program. Okay, which means, of course, that when we get to this point in the code here, we have depleted the entire list. Okay, so that's why we need to copy before we do this. Okay, always copy before print. So we're going to say that copy S1, which we defined up here as an empty one. It wouldn't have to be the same size, but we just made it the same size. Let's go say it's equal to S1. Okay, that we'll use our copy constructor that'll copy it over. So when we're done, copy S1 will be empty, but we should still have that top value of S1 should be 35. Okay. Let's compile that. Let's run it. Still does not like it. Why does it not like it? I wonder what I didn't do. Oh, because I didn't change my code. You have to change all the code. Yeah, I want to copy the copy S1. That's why I didn't do anything. copy S1 here. And most importantly, copy S1 there. Okay, that should fix it. Okay. Yep. Okay, so again, looking at our test code that we have so far, we're testing the constructor with a 0, we're in less than 0, it's going to default to 100, which is good. Okay, we're then going to create, we're pushing a 5, then a 15, then a 25, and then a 35. Okay, and note what this has done. This is where stacks are used a lot. It reverses things. The 5 was the first item to be pushed onto there, but it was the last one printed. Okay, that's that first in, last out. 35 was the last in, first out. Okay, and then since we made a copy now after the print, 35 is what's at the top. Okay, so remember, the only way to iterate through a stack is to destroy it. Okay, so if you want to not destroy it, if you want to print it or make changes to it or whatever you're doing, then you have to make sure you make a copy of it before you go through anything that does a pump. Okay, so that's the second part of arrays. Sorry, second part of stacks. It's an implementation of a stack using an array to hold the data. Okay, so in the next video, in part 3, I'll talk about but not implement some things to think about when you're implementing a stack as a linked list.